Hi. So I'm Julius, this is Björn. We are both from SoundCloud, and we are working in the production engineering team there on a new kind of monitoring system that you might have heard about. It's called Prometheus. And yeah, so when Todd asked earlier in his keynote, who's working more than 20% of their time on monitoring, that's us. Very coincidentally, we are also ex-Googlers, so this almost feels like home to be here again. Okay, so today we're going to tell you a bit about that monitoring system, but first a bit of history. So I joined SoundCloud back in 2012, and back then there was already a migration going on at the company. So SoundCloud initially started out as one monolithic Rails app, which did everything from rendering the website to handling the public API and the different mobile APIs. And that small Rails app quickly became really, really big. Nobody understood it anymore. Nobody wanted to add features to it anymore. And it basically became one big unmaintainable mess. So we lovingly called it the mothership. And so when I joined, there was already this migration going on from this big monolithic app to a set of microservices, where the idea was that we don't add stuff anymore to this mothership. We extract functionality or add new functionality into a set of microservices that do their own thing each. So for example, we might have one microservice or one set of microservices just taking care of the search functionality, and another set of microservices taking care of the stream of the people you follow, and so on and so on. And by that time, we already had hundreds of microservices, and I think now we have thousands of instances of these microservices in total. And for developers to be easily able to deploy these all the time and every day, we actually built an in-house Heroku-style kind of cluster manager that just finds available resources on a cluster of machines and then schedules these instances whenever someone deploys, schedules instances on kind of random hosts, on random ports. And yeah, so now you have this random assignment of services to machines and ports, and you have many of these services and many instances. How do you monitor that? How do you know when you canary something, is it still working? If something, if shit hits the fan, what is actually broken, and so on. So our existing monitoring setup for that in 2012 was twofold. First of all, we had, of course, service monitoring and host monitoring. And the service monitoring, I mean, we had some other stuff like New Relic for the Rails app and so on, but basically for time series-based service monitoring, we had this contraption of a single statsd and Graphite set up in the company. Just hands up if you've worked with that before. Okay, so you might know it works, but it's not ideal. The way it works is that you instrument your services with one of the statsd client libraries, and then for every event that you actually handle, whether it's an HTTP request or some other thing that you handle, you would send a UDP packet to statsd. Might also be like every 10th thing you handle, so there's subsampling that you can configure, but still, for basically proportional to the amount of work you handle, your monitoring traffic goes up and down. And when I joined, the statsd instance, the poor single one in the company, was already kind of falling over, throwing away UDP packets left and right, single-threaded Node app, so yeah. And then the idea is that statsd aggregates all these events, counts them over a window of 10 seconds, and then finally, out of all these many events, writes a single data point for that metric into Graphite. So that's already one kind of thing where you think, why doesn't the service just increment the number in memory, and then every 10 seconds sends that somewhere, or something like this? But the bigger issue is the underlying data model. So fundamentally, in Graphite, every time series is identified by one metric name, and these metric names may contain dots, and people usually encode implicit dimensions into these dots. So you could have something like API server dot get dot 200, and those would be the successfully handled GET requests by that API server. So you have this implicit encoding of dimensions into the metric name, but the query language allows you to work with that a bit, but not super ideally. And Graphite is also not that great scalability-wise with working with a lot of these dimensions, and if they're constantly changing. So if you want to track something like the host and the port where some instance is currently running, if you want to identify actually per instance the source of a metric, Graphite blows up pretty quickly. We had that experience at SoundCloud where some people thought it was a good idea to encode that into the Graphite metric name. Yeah, so finally, the UI is kind of from the 90s, so it's also not that fun to work with. There's also, like, on the right-hand side, on the left-hand side, you'd usually have like this tree view where you can go through the hierarchical metrics, the dot-separated components. And then finally, there's host monitoring. There we mainly used Ganglia, which you run an agent on every node, and then cluster-wide, there are some points where that gets aggregated into round-robin databases, and you end up getting dashboards like these, which are not super flexible. There's no query language. You get these RRD files with fixed sets of times and so on, so also not ideal. And it's a separate thing from the service monitoring, so it's not really easy to correlate service metrics with host metrics. We did end up feeding all our Ganglia data into Graphite, so that was at least a bit possible. So for alerting, we used Nagios. So who used that? Or yeah, used it or uses it. It works, kind of. But it's also both UI-wise and conceptually a bit from the 90s. So the concept in Nagios is everything is a host or a service that runs on a host. And if you have something that's a bit different, like an instance that's just floating around in the cloud, or you have some cluster level check that just doesn't belong to a specific host or so on, you still need to squeeze it into that old model of thinking. And then Nagios also doesn't give you a very good way of silencing specific alerts by any kind of arbitrary set of dimensions that you're currently interested in. So all in all, this wasn't really that much fun. But luckily, just a month before I had joined SoundCloud, there was another ex-Googler joining us, and he was already in his free time building a new monitoring system. And yeah, he was very passionate about it, and I joined him in this effort. And we started this in our free time, but then we noticed that it was actually starting to work. Hey, we can ingest data, hey, we can query data, and we can graph it. And that's when we decided to actually introduce it at SoundCloud as the new monitoring system. Took a while, of course, but nowadays it's the new standard monitoring system at SoundCloud for new services. And it's called Prometheus.
So yeah, Prometheus. It's fun, kind of. The real Prometheus brought us the Fire, and Fire is something, if you've ever used it, you cannot imagine life without it. And that's a bit like Prometheus, monitoring Prometheus style. It's also, if you haven't used Fire, it looks dangerous, weird, useless. So we try to explain Prometheus to people who haven't used Fire yet. By breaking it down to 4 important features, none of which is actually so great or even new, but in combination it's actually quite helpful. So the first thing is data model. We already talked about dimensionality. In Prometheus you have arbitrary dimensions. So you do something on a client, this is counting requests. Whenever you see total, that's by convention, it's a counter. So you don't send stuff per event over the network. You have the clients count things, but it doesn't just count all the HTTP requests, it counts them by dimensions. So you have, for an HTTP request, you have something like the method, an endpoint, a status code. Everything is counted separately in any combination you want. And when the Prometheus server collects those metrics, it attaches even more labels, like the instance this is coming from, the IP number, stuff like that. This data model looks pretty innocuous, but it's a core of the whole concept, and it's not new at all. OpenTSDB, another shining light in the dark world of open source monitoring, has pretty much precisely that data model, even down to the syntax. It's not quite the same thing, but almost. Next thing, operational simplicity. If you are Google or Facebook or something, you have a huge infrastructure you can rely on, and then you can run things like OpenTCP, where you, to run OpenTCP, you need a Hadoop cluster, you need HBase on top of that, actually HBase of particular versions, and then you run OpenTCP on top of that. And that is great, but if you are a mid-sized company, you have never run a Hadoop cluster, and you don't want to set it up just for your monitoring system, a bit of a entrance burden. Prometheus is written in Go, so it creates static native binaries, which is really useful. So you compile your binary in like 5 seconds or something, and you drop it on a host, and it just runs. No JVM required, no backend required. I mean, you need to configure it. We are glossing over that a bit here. You need to configure targets, but that's about it. You just run it, and it works. Third thing, scalability. The number of targets you have in a mid-sized internet company these days is it goes easily into the thousands. You just run in the cloud or something, have thousands of hosts to monitor and many services. Then you have to ingest samples, like hundreds of thousands of samples per second. And since you have this nice dimensionality, you have millions of time series, and you want to run this all on the single node. Actually, Prometheus is doing that. So these are about the scalability limit of a single Prometheus server. But if you want to scale even more, or you want redundancy or high availability, you can actually run multiple servers. That's easy too. Part of it, why this is easy, is that we have a pull-based approach. This is kind of a religious debate in monitoring. Do you push metrics from the client to the server? You may be overwhelming it, but yeah. Or are you pulling it so the server pulls in metrics whenever it thinks that's the right time? In Prometheus, we believe in the church of pull, because we believe it's actually simpler to operate and it's simpler to scale. I mean, it's all possible if the push model might just be more difficult. One of the things is you could just spin up another server, and since you pull in stuff, the server decides what to pull in, so it's no problem to run a Prometheus server on your laptop to see what the metrics look like, or just run another server for redundancy. So now this is the fourth and final thing. This is the query language. So this makes everything fit together. These are actual expressions from a real-world system. The Heroku-style cluster management system we use at SoundCloud is called Bazooka. And you can probably guess what those expressions are doing. The basic idea is you do very fundamental things on the client. There's no logic on the client side. You just do the most fundamental kind of metrics you can imagine. Then you collect all this data along all those dimensions, and then you ask questions later. So you have a query language, and you can ask all the questions in that query language. You can use it for alerts, for graphing, for everything. We'll look at that later in detail, but first of all,
yeah, so just to give an overview of the architecture of Prometheus, you would usually run one or multiple Prometheus servers in your company, depending on how big you are and availability guarantees you want to have. You'd configure them to scrape things that you care about. And these things that you care about could either be your own long-lived services running somewhere that you can instrument via one of the client libraries. And these client libraries give you access to the fundamental metric types like counters, gauges, summaries, and histograms. And you might also have some stuff that you cannot actually instrument directly, like host metrics or HA proxy. You probably don't want to go into the C code. I mean, there might be some nerds in here who want to do that and add Prometheus metrics and then keep that, like maintain that patch set. So we have exporters for that, which basically sit in front of the thing you care about and transform internal metrics into Prometheus format. So for example, we have something called the node exporter, which you just run on a Linux machine, and it exports all these procfs metrics that you're interested in as Prometheus metrics, and then Prometheus can go out and scrape it. Also, you might have things that are just too short-lived to be scraped, like cron jobs that delete users every day, and they want to report how many users did they delete. And for that, we have kind of as a gateway connecting the pull and the push world, we have the push gateway, where the push gateway is constantly running and just holding on to metrics that an ephemeral job sends to it. And then Prometheus can go out and scrape that. Prometheus then scrapes all these samples, stores them locally and makes them available for queries. So you can either go to like very simple built-in expression browser and graphing interface in the server itself, so that in case anything distributed goes down and your dashboard is down or whatever, you can still go to your Prometheus server that collected the data and inspect what is actually happening there. But usually you want to build dashboards, so for that we have also PromDash, which is a dashboard builder. And then finally on the right-hand side here, we have what's called the Alert Manager. Usually you would run only one of these per company, and the idea is that Prometheus or the different Prometheus servers that you have running can compute some kind of failure conditions on the data they've collected. So there's a flexible language for that too. And they would send alerts once they're firing to Alert Manager, and Alert Manager would then act as the kind of final clearinghouse for sending out notifications, so it can correlate different alerts from different servers and say maybe don't alert me for a job being down in a whole zone that's currently down.
Okay, so this is the expression browser Julius was just talking about, and the expression we have hacked in here is one of the expressions from the example, so we can dissect it a bit more. Bazooka stuff exports per instance very fundamental metrics like, I can actually point to things here. So memory limit is something a Bazooka task would reserve. And memory usage is the memory it actually uses, and it's all exported. So this is a very fundamental value. We can do arithmetic. We can subtract one from the other to find out how much memory we have wasted. This looks like variables, and we are just subtracting numbers. In reality, this is a lot of samples. It's a whole vector of samples along all those dimensions. So if we just subtract here innocuously, it's actually subtracting a whole lot of numbers matching by all those dimensions. So if we displayed that, we would see a lot of numbers here. So we want to aggregate that in a meaningful way. And this is where we get into the expression language. So we have a sum operator over there that sums everything up. If we did that, we got the number of bytes we waste across the company. It's kind of useful, but it's not really yeah, I mean, you want to find out the worst offender or something, right? So we can actually group the aggregation. In this case, we group by app and proc. If you've ever used Heroku, you know what that is. If you have never used Heroku, app and proc is basically, an app and proc pair is something like a service. So you do that by service. And then you sort it in the end. Another expression, you divide it by a couple of powers of 2 to get actually gigabytes, not bytes. And so we see this is the worst offender, right? Harsh Dagger API is wasting 132 gigabytes, and then we get all the list of things. Useful. It's a time series thing, right? So you can evaluate expressions at any point in time, and then you can graph it, and you see nice graphs here. And this is the other expression from the example. This is CPU time. This is another counter. It should actually be called total. It's breaking our convention.
Noted.
So if you count seconds on the CPU, okay, easy. And then you take a rate over a certain duration of time. If you take a rate, like seconds per seconds, what you get is CPU usage, actually. And again, you sum it up by app and proc, and you would graph every single Bazooka instance in the company. We don't want that. We want to graph the top 3 offenders. So we have another function for that, and you see beautiful graphs of the 3 worst CPU, or best, whatever. It's a good thing to use CPU, I guess. So another helpful thing you can get out of that. Yeah, let's.
So this built-in expression browsing and graphing functionality is great, especially for early exploration. And but at some point, you have built an expression that you actually want to put on a dashboard in a graph and want to persist that somewhere. So for that, we have different solutions. One of them is PromDash, the Prometheus dashboard builder. It's in contrast to most other Prometheus components, which are written in Go. This is a Rails application, at least still. And yeah, it allows you to click together with a nice graphical user interface, a set of graphs with advanced features. So you can have multiple axes. You can have data from different servers in the same graph. And yeah, legend format strings and so on. Other options we have is console template support, which are basically completely customizable HTML templates that you can that the server, a Prometheus server, can serve by itself. That's more of the power user use case. And there's also early Grafana support. So then just to show a bit more about what Alert Manager currently looks like, it's still probably the most experimental component of the whole ecosystem, but we're hoping to attack that next and bring that up to production quality. But the idea here is really that you have this chain of dimensions going all the way from your instrumented client application through the server to alerting. So if there's some dimensional label in the client, that gets stored by the server, and then the server actually can use the same flexible query language that we just saw for generating alerts, this vector-based query language. And in the end, alerts can then inherit the same labels as the time series that they're based on. So you end up knowing exactly which instance is failing, what sub-thing in that instance is currently having problems, and then you can also silence very specifically by any label set that you currently care about. So you could say silence everything in a particular zone if it comes from this job and that other label matches some regex, and silence that for 2 hours.
To make perfect use of Prometheus, you have to instrument your code. Instrumenting your own code is the heart and soul of Prometheus-style monitoring. That's kind of what stats the users already do anyway, so it might not be that scary. For like people who are stuck in the 90s and still use like Nagios-style monitoring, they don't know about that, right? You just run something and then you run an agent next to it which queries that something and does something, or you have something on your Nagios host that logs into the machine and does something or whatever, right? I mean, you can do that, but to make best use, take one of our client libraries, instrument your code. We have libraries in Go, for Java, Ruby, and Python. The Java library is more or less suitable to use by other JVM languages. SoundCloud is pretty much a Scala shop, so they are using it quite successfully from Scala. Other people have already started new client libraries. We have a .NET library, we have a Node.js library, and we even have, believe it or not, a Bash library. Is Adrian in the room?
Is Adrian here?
No. Okay, anyway. And we are super happy to have more libraries here. I mean, there are some gaping holes, obviously. Sometimes you are not in a position where you can instrument your code, and Julius already mentioned a few cases, like you want host metrics, right? So what would you instrument for host metrics? I mean, I guess you could instrument systemd or something, but we have so-called exporters for that. That's a bit like agents. So exporters are standalone binaries that collect data in some arbitrary way and then export Prometheus metrics. So we have stuff for MySQL. It's not even on the list, I think, because ecosystem is evolving quickly. But similar things like Redis exporter, Mongo exporter, stuff like databases you don't want to instrument yourself, so you have something that runs next to it and exports it. Then we have exporters that export metrics from other telemetry systems. Like we have a graphite exporter, a Collecti exporter. Often you have those systems in place, so you can run one of those exporters to export all those metrics into the Prometheus universe. Quite useful. If you're the luckiest of persons, you might actually already be running a binary that has been instrumented for you. CAdvisor might be something you're using already. Just upgrade to the latest version, you have Prometheus metrics. Kubernetes uses a bit of it, etcd uses a bit of it, and then there are some generic metrics libraries out there, like for Go, GoKit, or the Go metrics instrumentation library. They have modules for Prometheus, which you can just use, and then you export Prometheus metrics. And we were so happy, the most important thing in the world has Prometheus support now, the Minecraft server. Oh, that one.
Just this one. Yeah, so that's all we're going to tell you about Prometheus itself today. If you're interested in learning more, head over to the website, prometheus.io, or check out the SoundCloud blog post about it on our SoundCloud blog, or the Box Ever blog, where Brian Brazel, yeah, that's the right pronunciation, he's sitting there, published a lot of interesting articles about monitoring different things with Prometheus. So finally, just some thanks here. SoundCloud has been in the last years the main user, but also one of the main sponsors and contributors to Prometheus. There's too many people from SoundCloud to mention and to thank here now. But there's a very special thanks to our founding father, the guy I started this with in 2012, Matt Proud. And also very special thanks to Brian Brazel and Johannes Fisch-Ziemke from Docker, who were both already testing the system a lot and contributing back while it wasn't even officially kind of published. It was open source from the beginning, but we only really made noise about it starting this January. Cool. So there is also a workshop going on tomorrow, starting at 12:30, I believe, about Prometheus. Brian, are there still seats there? Is there still anything? Okay, so there's apparently still 6 seats available in that workshop if you're interested. So come join us. And we actually have 4 minutes something for questions.
Where's the thing? Ah, he still has it. So, any questions? To your left.
Do I just, okay, there we go. Cool. So you mentioned that this is all a pull process. I don't know if I missed it, but what protocol is it actually talking to the client libraries with?
Yeah, so it's talking HTTP. And usually, you would configure your Prometheus server to scrape every 15 seconds or 30 or whatever you're interested in. And then over HTTP, there's 2 transfer protocols that we currently support. If you go to one of these metrics endpoints as a human in a browser, you will get a very nicely human-readable text-based format. If it's the new server, if it's a client library already supporting the new text-based format, it's 1 sample per line with all the dimensions. If Prometheus goes and queries an endpoint, it prefers getting, via accept header content type negotiation, getting a more efficient and robust protobuf transfer.
But the server itself speaks the text format as well.
Yeah, it speaks both, so it can fall back to the text format as well.
Which is, by the way, you can do some kind of library-less exposition by just having those text lines created by a shell script even. So even that is possible. It's pretty simple, the format. Okay,
There's someone up there. Ah, okay.
So I don't know if you mentioned, I didn't see it. Do you guys support histograms, scraping histograms, or?
So histograms, my favorite subject. So we had a really long discussions, and histograms are actually really hard in a way. I mean, in a surprising way, perhaps. On our Prometheus.io page, we actually have a whole chapter just about histograms. We have 2 different kind of histograms to do that probably. So you can either let the client pre-calculate quantiles, which has some advantages, but has the huge disadvantage that you can never average over quantiles. There's actually famous talk about that, right. Not by us. So we also export a different type where we have bucketed histograms, and then the server knows how to deal with them, and your functions to calculate arbitrary quantiles. You just have to find the right bucketing scheme to get accurate values out of that. But it's definitely supported. Over there.
Talk here, okay. So 2-part question, one following on from the other. You're using a pull protocol, so how do you know which nodes to pull from? I'm thinking of the example where you might have a stack in AWS, for example, and the block of nodes changes on a regular basis if you're deploying 5 times a day. And the second part of that is, say you have a service X cluster, and you want to monitor how that performs comparatively throughout over a time period, but the actual nodes that are changing in that cluster, the nodes that are part of that cluster change. So can you group those nodes as the application so you can see the change over time, even if it's all on a set of different nodes?
Like a type of canary of a new version, or?
No, if you've got an application that's got 20 nodes and but you rotate those nodes constantly, you still want to be able to say the performance of this application over time is what it is. So you can compare different sets of nodes, but group them.
Yeah. So first question is, how are targets discovered? So the very simplest way is that you can configure them statically as HTTP endpoints. But what we're using at SoundCloud for most of the things, because we have this dynamic cluster scheduler where everything is just in flux all the time, we have DNS SD-based service discovery, so using SRV records to get the IP and port of the instances of a current service. But we have an awesome intern who just implemented much more generalized service discovery framework in Prometheus, which supports that, and a file-based service discovery where you can write your own targets into an external file, which is then watched all the time. And it will also support more common mechanisms such as etcd and console in the future. But through this file-based mechanism, you're basically able to plug in any kind of mechanism, at least from the outside. The second question, not sure if I understood it correctly, but you can always add labels to anything that you want to track specifically. So I guess, if you're interested in how service evolves overall over time, independent of its host, I guess you would just aggregate away the host, the instance dimension that tracks the specific IPs and ports where the stuff you're interested in is running on. But if you actually want to track the split between two things, like an old or a new component or a group or of old and new components, you can always somehow differentiate them with labels if you're interested in that. So you don't even need to attach it on the client side of your server, but you could assign different label sets on the Prometheus server side to different groups of targets that you're scraping. Not sure if that answers the question.
Anyway, you can catch us here in between talks, and we're out of time.
Yeah, the time is 0 here, and this is it.
Thank you so much.
Thanks.